Hi folks, we're going to take a look at number 11 from the October 19th homework, and here they're asking us to solve this system of equations. So I notice here I've got two equations, and again each of them involve the two unknowns x and y. So it is a system of equations, but obviously not, at least from the looks of it, doesn't look like a system of linear equations. Okay, we're going to still try to use one of our methods, and I think it looks fairly clear here that using elimination is not going to be an option, so I'm going to try to use substitution. Okay, so I'm going to start by trying to use one of these equations to isolate a variable. So if I look at this second one here, I guess I could rewrite this as x minus y to the negative 3 equals 8. Seems, a little complicated. I'm sure I could work with it, but I'm looking at the first equation, and I like that I'm seeing this 1/2 and this 16. Okay, the reason why I like that is because I know I can write both of these in terms of the same base. Okay, and so that's why I'm going to work with number 1, because I can solve for x plus y without having to take any logarithms. Okay, so let's see how we can do this. So I'm going to keep base 1/2 here. I'm not going to change that one, but I'm going to change 16 to a base of 1/2. Okay. So first of all, because I've got 16 and 1 over 2, I know that my exponent's going to have to be negative. Okay, and here the relationship between 2 and 16 is that 16 is 2 to the exponent 4. So if I take 1/2 to the negative 4, the negative 1 makes this 2, and then 2 to the 4th gives me 16. Okay, the reason why this is good is because I've got two powers with the same base that are equal. So if the bases are equal, the exponents must also be equal. And now I have a nice easy way of isolating either x or y. So I'll choose to isolate y here. So we have negative 4 minus x. Okay, so of course that's just the first part of substitution. Now I actually have to perform the substitution. I'm going to put that into the second equation. So since I used the first equation, I now have to use the second equation. So wherever I see a y, I'm going to replace that by negative 4 minus x. Okay. Okay, let's simplify here. So this becomes x plus x, so 2x, and here negative 4 gives me plus 4, okay, of 8 equals negative 3. So notice all of this is in the base of the logarithm. Okay, but now that I have a single logarithm equals a number, and even better, that base has only one variable in it now, I'm going to put it into exponential form. Okay, so this is going to give me base of 2x plus 4 to the exponent of negative 3 is equal to 8. Okay, now I'm going to solve for x. Now I actually think I can solve for x directly, okay, because I have that linear term of x, okay, and so what I'm going to do is I want to get rid of negative 3, the exponent negative 3 from the left-hand side of the equation. Okay, so I'm going to take the left-hand side to an exponent that's going to leave me with a 1. Okay, so let me think, what's going to make this exponent 1? Well, if I multiply negative 3 by negative 1/3. Okay, and I say multiply because here I'm taking the power of a power. Okay, and so of course if I do that to the left, I have to do that to the right. So now this negative 3 times negative 1/3 is just gives me 1. So I'm just left with 2x plus 4 to the exponent of 1. And here, well, you might be able to see the answer right off the bat, but you can also just change this to 1 over 8 to the 1/3, which is just the cube root of 8. And of course, the cube root of 8 is just equal to 2. So we have 1/2, so 2x plus 4 equals 1/2. So 2x equals 1/2 minus 4. Okay, so that's negative 3.5. Okay, and so x is equal to negative 3.5 divided by 2, and that's negative, so here 3.5, that would be 1.75. Okay, so there we have it. We have our x value now, and all we have to do is find our y value. Okay, but not much to do there because we already have y nicely written in terms of x. Okay, so I can take this equation here now, y equals negative 4 minus x, which is negative 1.75, and so y is equal to negative 4 plus 1.75, and what does that give us? So negative 4 plus 1 is negative 3. Okay, negative 3 plus 0.75, so I guess that gives us negative 2.25. Okay, and there's our y value. Oh, there you go, sorry. I was writing it down and didn't show you on the piece of paper. Okay, so I just replaced this x value in this equation here for y, okay, and found my y value. Okay, so let's recap this problem. So, number one, system of two equations and two unknowns, meaning we have to use either substitution or elimination. Here, substitution was the way to go. Because I had a way of writing this first equation using the same base, I worked with that one there to isolate my y variable, input it into the other equation, used my trick of turning a logarithmic expression into an exponential one, and then from there just solved. Okay, so if you want to take a quick look at the solution, there's the first part and there's the last part. Okay, that's it for now.